The confirmed visual documentation of the GJ-21, the naval iteration of the GJ-11 unmanned combat aerial vehicle, in active flight testing represents a definitive and significant milestone in a multifaceted, long-term technological and doctrinal development program. This event signifies a transition from theoretical design, prototype construction, and ground testing phases into the critical stage of practical, real-world aerodynamic and systems validation. The progression observed indicates that the project has successfully navigated initial research, development, and engineering challenges associated with creating a low observable, unmanned system capable of integrating into the most demanding and dynamic operational environment, the aircraft carrier battle group. The development of the GJ-21 is not merely an incremental upgrade but a substantial and complex re-engineering of the base GJ-11 airframe, necessitated by the unique and extreme physical demands of maritime operations. This transformation involves a comprehensive structural reinforcement of the entire vehicle. The fuselage, wings, and particularly the landing gear require significant modification to withstand the immense and instantaneous forces experienced during critical carrier operations. These forces are most pronounced during the landing phase, known as an arrested landing. In this maneuver, the aircraft, traveling at a high approach speed, must catch one of several arresting wires stretched across the carrier deck with its tailhook. This action brings the aircraft from landing speed to a complete stop in a matter of seconds and a very short distance, subjecting the airframe to extreme deceleration forces, or G-forces, far beyond those encountered in normal runway landings. Conversely, the launch phase is equally punishing. The GJ-21 is designed to be launched using the Electromagnetic Aircraft Launch System (EMLS), which is installed on the new Type 003 class aircraft carriers. While EMLS offers a smoother and more controllable acceleration profile than older steam catapults, it still imposes tremendous stress on the aircraft's nose landing gear, its attachment points to the airframe, and the overall structural integrity of the vehicle. Beyond these dynamic loads, the airframe and all its internal and external components must be engineered to resist the corrosive effects of the maritime environment, including salt spray, high humidity, and constant exposure to sea air, which can degrade metals, electronics, and sensors over time. A critical and visually identifiable modification specific to carrier-based aircraft is the incorporation of wing folding mechanisms. This feature is not for aerodynamic performance but is a logistical necessity for efficient operations aboard a vessel where space is an extremely limited resource. By enabling the outer sections of the wings to fold upward, the vehicle's overall wingspan is drastically reduced. This allows for more compact storage in the crowded hangar deck below the flight deck, facilitates movement on the ship's elevators between the hangar and flight decks, and enables more efficient parking and spotting arrangements on the flight deck itself, ultimately increasing the total number of aircraft the carrier can accommodate and support. The core design philosophy of the original GJ-11, centered on achieving a very low observable profile, commonly referred to as stealth, is retained and further refined in the GJ-21. The tailless flying wing configuration is fundamental to this objective. This shape eliminates traditional vertical control surfaces like tails and rudders, which are pronounced reflectors of radar energy. The entire geometry of the vehicle is composed of continuous, sweeping surfaces and carefully calculated angles designed to deflect incoming radar waves away from their source, rather than reflecting them directly back to a detecting radar receiver. Attention to detail extends to all apertures and openings. The engine intake, for instance, is situated on the top of the airframe and is likely shaped with serpentine or S-curved pathways internally to prevent a direct line of sight to the front of the engine's compressor blades, which are highly radar reflective. The engine exhaust is fully integrated into the rear of the airframe and is expected to be designed with a combination of cooling techniques, special coatings, and physical shielding to significantly reduce its infrared signature, making the vehicle harder to detect by heat-seeking sensors and infrared search and track systems. A paramount feature for maintaining this stealth profile during combat missions is the inclusion of an internal weapons bay. Unlike conventional aircraft that carry munitions on external pylons and hardpoints, which dramatically increase radar cross-section and aerodynamic drag, the GJ-21 is designed to carry all its payload, including munitions and reconnaissance pods, internally within a sealed bay. This ensures its radar signature remains minimized throughout the majority of its flight. The bay doors are only opened momentarily, typically just before weapon release, to deploy their payload, after which they are closed again to restore the vehicle's full low observable characteristics. The operational concept for the GJ-21 extends far beyond the function of a simple unmanned bomber or reconnaissance drone. Its intended use is deeply networked and multi-role, designed to function as an integral node in a modern carrier battle group's complex combat system. One of its primary functions is that of a penetrating surveillance and strike asset. Its low observability allows it to operate with a higher degree of survivability in areas defended by advanced integrated air defense systems, where non-stealthy aircraft would be at extreme risk. It can be tasked with conducting deep-range intelligence, surveillance, target acquisition, and reconnaissance missions deep inside contested or denied airspace. It would utilize its own suite of sensors, which may include electronic intelligence collectors, synthetic aperture radar for all weather, day-night imaging, and electro-optical infrared sensors, to gather critical data, identify and precisely locate high-value targets, and even designate them for other platforms. In a subsequent strike role, it can then engage these targets itself using precision-guided munitions, such as laser or GPS-guided bombs and air-to-surface missiles, carried within its internal bay. A more complex and strategically transformative role envisioned for the GJ-21 is its function as a loyal wingman, or more accurately, an unmanned team member operating in close concert with manned fighter aircraft like the J-35. In this distributed warfare concept, a flight led by one or two J-35 pilots would act as mission commanders, controlling and tasking a group of GJ-21s. The manned fighters, leveraging the pilot's superior situational awareness, cognitive reasoning, and decision-making capabilities in complex and dynamic scenarios, would remain at a safer distance or in a more advantageous position, while directing the unmanned vehicles to perform the most hazardous tasks. The GJ-21s could be sent ahead to scout and probe enemy air defenses, acting as forward, expendable sensor nodes that build a comprehensive and real-time picture of the battlespace for the J-35s. They could be commanded to engage enemy aircraft with their own beyond visual range air-to-air missiles or to attack heavily defended ground targets, effectively acting as additional, long-range missile magazines that extend the reach and lethality of the manned flight. This distribution of capabilities across multiple platforms creates a more resilient and adaptable force. The loss of a single unmanned vehicle is a tactical setback, not a catastrophic loss of a pilot and a highly complex manned fighter. Furthermore, the ability to control these vehicles in coordinated groups, or swarms, presents a profound tactical challenge for adversary air defenses, potentially saturating their sensor and engagement capacities with too many simultaneous, low observable threats. The effective integration of the GJ-21 into fleet operations is entirely dependent on its interoperability with specific, advanced supporting infrastructure. It is designed from the outset to be launched and recovered from the new generation of Chinese aircraft carriers, specifically the Type 003 Fujian and any subsequent vessels, which are equipped with the electromagnetic aircraft launch system. This system is considered more efficient and flexible than traditional steam catapults, as it can be precisely calibrated to launch a wider variety of aircraft weights, including the potentially different stress and acceleration requirements of unmanned systems like the GJ-21. Furthermore, the GJ-21 is designed to operate in seamless conjunction with the KJ-600 airborne early warning and control aircraft. The KJ-600, equipped with a large rotating radar dome and powerful computing systems, can see over the geographic horizon and track a vast number of air and surface targets at long range. It can act as a central information and battle management hub, detecting and tracking hostile forces and then securely relaying this targeting data to the GJ-21 without the unmanned vehicle having to activate its own, potentially weaker and more detectable radar, thereby allowing the GJ-21 to remain silent and stealthy until the moment of engagement. The first flight of the GJ-21 is a tangible and significant indicator of a strategic shift in naval aviation doctrine, moving unmanned systems from peripheral and supportive roles into the central core of future strike, air combat, and intelligence, surveillance, and reconnaissance operations. The development and ongoing testing of this system signal a clear intent to create a future carrier air wing that is more distributed, more survivable against peer-level advanced integrated air defense systems, and possesses greater operational reach, tactical persistence, and overall lethality. The progression to active flight testing confirms that the program is in an advanced engineering and systems integration stage, successfully resolving the myriad practical challenges of carrier aviation and steadily moving the concept from a demonstrator technology toward a deployable and transformative naval asset that will inevitably alter the tactical and strategic calculations in maritime domains around the world.